In this video, we'll talk about square root functions on a basic level. Now, square root functions are also sometimes referred to as radical functions. Radical functions is the family that all these root functions fall under. So let's talk a little bit about the origin of a square root function. And we've talked about inverses a little bit already. So if we think about y equals x squared, okay, it's a parabola, goes to the origin. That would be the minimum, and it keeps this kind of nice parabolic shape here. Very symmetric. Now, if we think about what the inverse of this would be, logic would kind of dictate the inverse of this function would be y equals the square root of x. Now, if we reflect this over the y equals x line, what's going to happen is we'll have this kind of shape like a tilted parabola. Now, what ends up happening is usually when we take a square root, we take the plus case and the minus case. Now, when we talk about a function, if we were to do a vertical line test, I would hit this red curve twice. This would be not a function. So what we end up usually doing is we just neglect the negative half. We omit it just for the sake that we can have a function here. So it's worth noting it's a small thing. Yes, the square root of x is an inverse for x squared, but only for values of x that are positive or 0. So that's just worth noting. X has to be greater than or equal to 0 in this case. And that will lead us into our next point. So let's talk about domain. Domain is a list or a set of all possible x values. And usually I wait to talk about domain and range until we get to this section, because when you're talking about lines, when you're talking about polynomials, it's pretty rare that you have restrictions, with the exception of quadratic functions. But even then, you know, this is a good time to talk about it. So if we think about the graph of a square root function, it looks like half of a tilted parabola. Now, the big thing is that whatever is underneath the radical, so in this case x, has to be greater than or equal to 0. So what we can do is we can set whatever is underneath the radical equal to 0 and solve. So say we had y equals the square root of x minus, 3. And I want to know what values can I plug in for x where I will have either 0 or a positive value. Because I can't take square roots of negatives along this coordinate grid system here. This only applies to real numbers. If I can't take the complex numbers, I wouldn't know how to graph that. So what we're going to do is we're going to set just what's underneath the radical equal to 0. And then we'll solve that equation. This will tell me x at its smallest can be 3. So this would tell me x has to be greater than or equal to positive 3. That would be my domain. So x can be any real number so long as it's greater than or equal to 3. So this would be my domain right here for this particular example. We'll do another example in this video just to kind of re-illustrate, but for now let's talk about range. So range, very similar kind of thing. If we look at default square root of x, what's going to happen is we're looking at the y values now. So going across up here, what values do I hit? I don't get any negatives again. So y has to be any real number so long as y is greater than or equal to 0 for the default, y equals square root of x. Now, if it changes, let's take a look at our y equals square root of x minus 3 example. Well, we've already determined that x has to be greater than or equal to 3. So what I'm going to do is I'm going to plug in my smallest value. And then we'll see what we get, because that would tell me what my smallest y value is. In this case, y is going to equal the square root of 3 minus 3, which is 0. So in this case, y has to be greater than or equal to 0. It doesn't change from the default. And again, y has to be a member of the real numbers. That would be my range. So let's put this together. we'll do one example. We're asking about domain and range. I think it's easiest to start with domain, and then we can do the range. So, if we're thinking about this equation, we have y equals the square root of x minus 3 plus 1 after we're done with the square root. So I'm thinking domain, what I need to do is I need to look at just what's in under the radical. So x minus 3 is equal to 0. That'll tell me what my smallest value is, because at most, or at the least, it can be 0. It can't be negative. So this would tell me x has to equal 3. That's the smallest value. So this would tell me x can be a real number, and x has to be greater than or equal to 3. It can be any real number so long as it's equal to 3 or bigger. There, I'm done with domain. Now we're going to look at range. We're going to take this value and we're going to plug it in for x. So y is going to equal the square root of 3 minus 3 plus 1, which means y is going to equal the square root of 0 plus 1, which means that y is going to equal 1. Now that is my smallest y value right here. So we're going to go with that thought. We're going to say y has to be any real number so long as it's greater than or equal to 1. And this would be my domain and my range all put together. Just one way of doing it. In another video we'll talk about transforms, and that's another way of thinking about these functions, and we can do domain and range using the graphs if we so choose.